It is my great pleasure and honor to welcome you to this event organized by the Italian Institute of Culture in Edinburgh, Artificial Intelligence between Research and Industry. We are going to listen to a very prestigious range of speakers that in different ways operate between academic research and industrial research, between research driven by intellectual curiosity and research driven by the needs of market. The very first thing we are going to do this evening is to listen to a message from the Consul General of Italy, Fabio Monico, that welcomes to this event and sends you your greetings.
Good evening, everyone, and thank you for being here tonight. I am extremely proud to launch today a series of webinars that aim to bring together different fields of interest for Italy, but we hope for Scotland too. Our first webinar tonight focuses on artificial intelligence, something that is becoming more and more part of our daily life. But in order for it to improve, it is necessary that research and industry interact continuously and effectively to bring further progresses to our lives. Tonight's webinar will analyze how this interaction can happen and can be maintained. We are looking forward to listening to our distinguished speakers, which I would like to thank warmly, and who fully represent a successful example of what I've just mentioned. I wish this webinar can stimulate further cooperation between not only research and industry, but also Italy and Scotland, in spite of the challenging time we are all living in. With no further ado, I now leave the floor to Alessandro Vincerelli. Thank you again.
So thank you very much. And we can start with no hesitation with the speaker. Our first speaker will be Professor Rita Cucchiara, full professor of the University of Modena and Reggio Emilia in Italy, the University of Ferrara. And Rita is not only a great researcher, but is also a person that plays in Italy a very important role of coordination of all artificial intelligence activities in Italy, and in particular of the relationship between academic and industrial research. So Rita, the floor is yours. You can share your slides with us if you have. Thank you very much.
Okay, thank you very much for the invitation, and I hope you can hear me. So actually, thanks for also the presentation. I'm trying a few minutes to give you an overview of what we are doing in Italy. And then after 2 slides about everything in Italy, I would like to concentrate to what we are doing in our lab. Even of course, everything is very strictly related. So as Alessandro told before, I'm this moment, I am the director of the National Laboratory of Artificial Intelligence and Intelligence System that is under the endorsement of the Italian President's Council. And I'm also the coordinator of the table of artificial intelligence in the Italian Research National Plan 2021-2027. And so we are actually writing in this moment our strategy, not only for research, but also for research in industry. In few words, what is the National Lab is actually just only a network. It's a but it's a big network because it's a big network composed with 55 nodes in mostly all the university in Italy, and also the Italian Institute of Technology, the CNR, and the Fondazione Bruno Kessler, and connecting more than 1,000 researchers, full research in AI, not considering a PhD student and everything else. So it's really a big network, and what we can try to do together actually is to find the good approach for the triple helix, putting together research, institution, and also industry. I mentioned the triple helix because last week we did a bilateral meeting, Italy and Canada, actually for working in this direction to put together research, institution, and industry, as we are doing today. And I could spend a lot of time discussing what we are doing, but the things that I like more is that we started with a document that is called AI for Future Italy. There's the connection here, so we can have the document by Google, where we started to think about some recommendation in Italy about the future of AI and the future of Italy. And we are very happy and very proud that the idea that we started to write last year at the end has been considered in the Italian strategy of AI, both the one of Ministry of Economic Development and the one of the Ministry of University and Research. As well, we are doing a lot of bilateral meeting. For instance, we are organizing an Italy, Israel, and the Emirates group for AI and cyber for health that I would be very proud to share also with the UK and with Scotland, of course. As well, just to mention one thing, we are creating a joint center together with the Italian supercomputer facilities and NVIDIA in an initiative that is called AI Nation, that is around all Italy. And we are opening some technical research center. The first has been created in my lab, but now they are spreading more or less everywhere in Italy. So now, since we have really few minutes, I would like to spend the last minutes to present what we are doing in Modena. Modena, my university, is actually a university that has 3 different campuses in Modena, in Reggio Emilia, and now also in Mantova. And where we are doing a lot of in computer science and computer engineering. And for the part of AI, as well as the NVIDIA Center that I told before, I'm very proud to say that now from September, we are an ALICE unit as a IIT, together with the University of Firenze and the Cineca HPC Center. And we have also a joint lab with Ferrari that's called Red Vision about human and vehicle interaction. As well, we are created what we call AI Academy under the supervision of the Regione Emilia-Romagna in order to create the contact of technology transfer, but especially for educational, lifelong education for industry in AI. Few words about AI. We are not working in every field of AI, but as our friends, we are concentrated especially in computer vision and machine learning and deep learning, applied in 4 different fields: in security, in human-centric industry, in human and health, and in human-centric culture. Just some images of what we are doing, and then we can discuss after if you want. As I told, we have a joint lab with Ferrari for human vehicle interaction. We are working with the designer of ceramic tile for generative neural network for supporting the creation of new marble or new ceramic with this company. We are working with the Italian railway company in order to have anomaly detection testing our algorithm of anomaly detection. And an interesting project we started last year, and we are working a lot with the Tetra Pak that actually is from Sweden, but the research labs are in Modena in order to still working on human and machine interaction. Another example of what we can do with industry that is similar, even is in a completely different field, is what we are doing for fashion, and especially for high luxury fashion with the Yux Net-a-Porter group, that is the Richmond group, working with us for some research in what is called VTON, so virtual try-on images on the people. We are creating the biggest data set of images in this field in order to understand how we can improve the experience of the customer. some European projects that are connected, especially for predictive analytics in Industry 4.0, and some that I'm very proud of this, because now this has become also a startup for working for distance-based risk estimation for human safety, that now is empowered by team, and we have a joint venture with a team. For this team is an Italian company of telecommunication. This has been done also with Italian ministry part, and also in some European projects. This one that is called Perseo is a new Marie Curie project for personalized robotics, for AI for personalized robotics, that is starting in 2021 with several universities in UK too. I skip one because the time is over, but I would like to spend one words about another field that for me it's very important, that is AI and machine learning for cultural heritage. Working on picture analysis, understanding the content of picture, understanding the handwritten document and interaction. We are doing this with some Italian project, but also with a bilateral project, Italy and Israel, that started last year under the supervision of the Italian embassy in Israel. And also with some experiment on human and museum interaction. This is an example of what we did last year during the Festival of Philosophy in Modena. And this is another project we are doing with aceto balsamico, the Italian vinaigrette area that is important. Finally, last but not least, AI for human and health. We are working in a European project for the new deep learning library for machine learning with this project that I believe is really interesting. And really the last one is about our ongoing research with ESA, with the European Space Agency, for analysis of geodetic and geostationary data in coming from satellite. Our lab, together with the other lab of the CINI, is strictly connected with the European network. In particular, we are part of this 3 European project of ICT 48, Human AI Net for human AI interaction, the CLARE, but especially in ELLIS, because also, as I told you, I'm ELLIS fellow and my group is a part of the unit. Stopping because the time is not a lot, but then we can discuss together after in the panel. Thank you, and cheers.
Thank you very much, Rita, for this very exciting presentation. I'm sure there will be a lot of questions later about, and we can move to our second speaker of the evening, who is Stefan Raue. So Stefan has a different path between research and industry. He started as a PhD student and he discovered a vocation of entrepreneur during his PhD studies, and is now literally a serial entrepreneur. He has created multiple companies. So I leave the floor to Stefan for his presentation, where he will tell us about his interaction between academia and industry. Thank you. Stefan, please.
Thank you very much, Alessandro, for the introduction, and good evening, everyone. So today I'm going to talk about artificial intelligence and the trends that we envisage when we work with our clients and on our own products. Arceptive is a technology and business consultancy, but we are also a product development company developing our own intelligent products. Our focus really lies on scalable data processing and analytics pipelines, and very much the development of business software in the B2B space. We often deal with projects that have some kind of connected devices, IoT devices that generate loads of data, and we're helping clients to make sense of that data. Compared to research, our projects are often very short, 3 to 12 months. And rather than showing that something works, we often need to produce something in with the client that actually has a commercial value at the end. We are based in Glasgow in Scotland, beautiful city, as you can see from the image. And as I mentioned, very much our focus is on data processing and analytics pipelines. for resilient web platforms. I just wanted to have a quick overview over the terminologies that we're using when we're talking about machine learning and artificial intelligence. And I thought that's a great overview, with artificial intelligence basically being the technique that enables machines to mimic human behavior. And that could include anything that is perception, language processing, or some kind of reasoning. Machine learning is a subset of artificial intelligence techniques which use statistical models and methods to basically improve the experience of machines. And deep learning, again, is a kind of subset of machine learning. Something that I wanted to highlight from an industry perspective as well is the term data science, which is often used as a set of tools and techniques that actually help us to go through the early discovery stages all the way to data preparation, model planning, model building, and actually communicating results with the clients and operationalizing, which I think from an industry perspective is very important, operationalizing these novel techniques that actually have commercial output. So I'd like to take you through 3 example projects that we've worked on this year and use these examples to highlight some of the trends that we are envisaging. The first one is focused on sports and performance analysis. And in this project, we looked at sensor-based inputs. It's a device that's worn by the athletes, and the data is collected for motion on the player itself, as well as location on the pitch, location data on the pitch. So very early stages of this project, the client was only interested in descriptive statistics. How far has somebody run? How quickly somebody moved on the pitch? But as you can see, when people are starting to understand their own data, they will want to know more. And this is where machine learning to extent came in for this project, where we then had to apply predictive analytics to see if we can actually predict injuries of certain players based on their previous running behavior, based on their previous motion analytics, to then see if we can predict injuries before the player actually got hurt. The next step then in discussion is the move towards more artificial intelligence. So you've now collected the data, you've done some kind of analysis over a big corpus of data, but now you want to work with, for example, domain experts like physios or performance coaches in the sporting environment to do some kind of reasoning and trying to determine what the best course of action is, for example, to prevent those injuries. So suddenly the system needs to work alongside those domain experts, and rather than just producing numbers, it now needs to explain how it came up with certain predictions or suggestions that it comes up with. So one of the trends that we can see that machine learning often is regarded as this black box, but once it goes to the point where it has to communicate and reason together with humans, we need more explainable outcomes, and the outcomes of those machine learning algorithms need to be explainable. So explaining machine learning outputs is one of the trends that we see in this project. Another project that we are working on is indoor air quality monitoring. And again, we have a sensor-based input. Data is collected, environmental data from a domestic environment or commercial environment. We have direct interaction with the end user. And in a domestic environment, this end user could be a child as well as a teenager, an adult, or an elderly person. So you're dealing with multiple demographics. And here the context is that we are seeing lots of traditional device manufacturers, such as air quality monitoring devices, now requiring to add a layer of intelligence to their traditional products. Often they do not have these capabilities in-house. And the trend that we are seeing is that third-party systems, for example, that enable voice interfaces are now increasingly integrated into those devices. And the next step we see is contextualizing those kind of third-party services to, for example, for voice interfaces, find the right tone or right message depending on who this device is talking to. And finally, one project that we worked on earlier this year was in regards to climate change and built environment monitoring. So here we have sensor-based environmental sensors as well as a vision-based input for our machine learning models. And the target here was to determine the thermal properties of large regions within cities. So rather than looking at how energy performance is for an individual dwelling, we would be looking at thousands, if not tens of thousands of buildings in an environment. And we quickly identified that when multiple companies, stakeholders, and organizations come together to collectively work on complex models by either contributing their own data sets or by all taking outputs from a machine learning model, governance becomes very much important. So that's data governance as well as machine learning model governance to determine who can access which elements and who can control the data and who can control the outputs. So in summary, for us, all projects start with data. Very much the quality and the scale volume of data determines what you can do in your project. In industry, we often have shorter term projects that requires productionizing a solution rather than just showing that something is possible. We often have to show a commercial value at the end of that project. And three main trends that we are seeing in the work that we do is that machine learning outputs and intelligent systems basically need to have more explainability of those outputs. As machine learning and computing power becomes more a commodity, we see more organizations adding a layer of intelligence to their products. And we need to see how we can contextualize these third-party applications that they integrate into the environment that they deploy their products into. And finally, as we see more organizations engage in machine learning and artificial collaboratively, especially in public sectors, it becomes more important to have very strong data and machine learning governance models in place to control access and of data and model outputs.
Thank you very much. And we move to another young entrepreneur, which is Olivia Gambellin. And Olivia has a very interesting story. Olivia is probably one of the very first graduates in the world in AI ethics as a philosopher. And you will not expect a philosopher to become an entrepreneur in a very technologically oriented field like artificial intelligence, but she did. She's a CEO and founder of a very interesting company called Ethical Intelligence. And so I think it will be very interesting to listen to her path from research to industry. Olivia, the floor is yours.
So as Alessandro mentioned, I am the founder of Ethical Intelligence. We are an AI ethics advisory firm, and our mission is to bring the human back into the equation. So also, as Alessandro mentioned, I am proud to say I'm a philosopher by trade, which is often very surprising when I walk into a room of programmers to say that I am a philosopher. They're often quite taken aback from that. The whole process of how I went from academia into industry was very focused on time I spent in Brussels actually studying and researching in GDPR and data privacy. I came from a previous background of working closely in ethics and morality in my academic career, transitioned into more research, was caught up in the discussion around data privacy and stumbled upon a small field called data ethics, which later led into the field of AI ethics. Upon discovering that, went back into academia to, let's say, prep for trying to go out into industry and help with this greater issue. And since then, I have been working on ethical intelligence. We also sit in between this gap between academia and industry. I'll go into this a little bit later, but we have an expert network of now close to 40 experts in academia that we work with in applying their knowledge straight into industry. So before I go too far into that direction, I want to talk really quickly about the typical efforts you'll see in this space. Since we are such a new field, AI ethics, tech ethics, you can group us all into that, under that same umbrella. You'll also hear us referred to as responsible tech even. It's a growing grassroots community. There are some frameworks that are quite common to find. And I want to go into those quite briefly here about how they're coming out of a very academic research base in philosophy and how they look like in the actual AI industry and how they're being applied. So the first one, and I'm going to go through some ethical frameworks, there's 3 of them. The first one is duty ethics. You'll often hear this either called deontological, Kantian ethics. Essentially, all you need to know here, duty ethics, it's an ethical framework which is rule-based. You're concerned with the actions of the person. This is how you're looking at the actions, whether or not the actions are right or wrong, in accordance to a hard set rule, a hard set list of rules even. So how this looks in the current AI industry is all of the different policies and ethical frameworks we're seeing come out. So a great reference for this would be the European Union's high-level expert group with their ethics guide in AI. That would be loosely based on deontological ethics. It's a list of principles that must be followed and loosely how to follow them. That is, again, deontological. One of the problems with this framework, this ethical framework, is its lack of flexibility. Oftentimes you can end up with skewed answers because you're focused on following the rule and not paying attention to the consequences. It's easier to code into systems. So this is a popular way to approach actually embedding ethics into technology, but there are many pitfalls here that must be addressed. The next one I want to go over is consequential ethics. This is also commonly referred to as utilitarian ethics. It's not an interchangeable, but you'll often hear utilitarian and consequential used in the same context. Essentially, instead of looking at the rules and the actions of the individual, this framework is looking at the outcomes of an action. So you'll often hear, what is the greatest common good? That is the action we need to take because it results in the greatest common good. So if we're looking at the trolley problem and we're deciding whether we're going to run over 1 person or 5 people, if you're trying to abide by utilitarianism, you're looking at, well, 5 people are greater than 1 person, so we run over the 1 person. How this looks, again, in the AI industry is ethics audits. We're looking at models, we're looking at systems, and we're determining based off of the outcomes, the output, the efficacy of the actual system. So looking at the impact. This is often encompassing stakeholder assessments and stakeholder impact assessments, both direct and indirect, looking at not only the user base, how the users are affected by this, but also indirect users. One of, again, the problems here is the overemphasis on the shareholders. Oftentimes, industry gets caught up in, we must meet our shareholder profit turn, our profit margins for our shareholders. And that becomes then the emphasis, and that becomes the marker of, well, the consequence of this model, as long as it brings profit to our shareholders, is good. So there's this kind of misconception happening in industry. And again, you can have some skewed outcomes here as well using this framework. Another downfall to consequential and duty ethics is the lack of ability to adapt quickly to both cultural context, sector context, and pace of innovation coming from industry. These are problems that industry faces and don't quite match with these 2 frameworks. So again, these are ethical frameworks coming into industry. The last one that I'm going to go over quickly is virtue ethics. This one you'll see least amount of in terms of an actual AI application. It's the hardest to code for because it depends on the person, the context, and what virtue you're trying to uphold. So again, you were looking at, let's take the virtue of courage. In this context, this person is courageous. They're in between reckless and cowardice. They're courageous in the middle of it. So it's all about this balance. It's looking at, is the person virtuous? And actually built into virtue ethics is the need for education and training and the building of habits. So how this looks in AI and industry is actually training and education. One of, again, the big qualms coming from industry is that the engineers, the programmers, the computer scientists did not receive any education whatsoever in academia for ethics. So now there's kind of this retrospective action happening, trying to educate the people working and developing these programs in ethics. So they've at least got some sort of understanding. So how does EI bring academia into industry? Again, we're ethical intelligence. We go by EI for short. So one of our missions, we're empowering human-centric technology by making ethics accessible and affordable. What we concentrate on actually is virtue ethics. We use virtue ethics and we apply it directly to startups and SMEs. So we're looking at the people that run these companies and how do we train them to spot, mitigate, identify, and overcome these ethical challenges. So really giving them the training. In philosophy, we call this moral attention, to be able to identify an ethical situation. You can train for that. It's building habits so that this is built into naturally how people are developing their systems rather than having to go through checklists that they find is cumbersome. How we do this is just about half of our expert network. So as you can see, there's lots of different faces here. And they are what we call our EI expert network. This is what we call our EI expert network. All of these individuals come from academia, strong academic backgrounds, and they are either working in industry, currently conducting research in academia, or transitioning from academia into industry. They are a wide breadth of individuals, and I'm honored to be able to work with them. What we do is we work with them on a client-to-client basis, as well as we try and bring their research through a practical lens so that it's easily understood and applied in industry, in the day-to-day work. So as I mentioned, our mission, one of our goals as a company at Ethical Intelligence is to bring the human back into the equation. Well, these are our humans, and we actually have something we call the equation. Quite literally, it was a fun little branding experiment, but the equation is actually a cyclical training resource. It's actually kicking off in January full steam. It's a monthly, it goes by monthly themes. In January, we'll be addressing well-being, and we'll be addressing how to create intelligent systems that enhance human well-being. And how do you prove that? How do you do that ethically? So we'll be looking at assistive technology. We'll be looking at mental health applications, that whole lot that's come out thanks to Corona. But essentially what this does, we are taking the expertise of our experts, and we are figuring out how this applies and how to teach it to technologists, to founders, to those startups, those SMEs. How do we teach it so that they can apply it? So again, this is the equation, and this is how we use that academic notion of virtue ethics and apply it into industry practice. We do run into quite a few problems because we're such a new industry, because this is a new field, both in academia and in industry, translating over from that research. These are kind of the two big challenges that we often run across. The first one is it's difficult for academics to gain access to the necessary data from industry for practical research in ethics. So academics are often running into the problem of, oh, it's a trade secret. Oh, we can't give our data out. Oh, we can't open up our models. Well, then the academics can't do the necessary research to have any input and any kind of feedback into companies and industry. It also goes in reverse. We see the same frustration coming from industry folks, where they are looking at these high-level discussions about singularity and consciousness problems with AI and going, this is great, but this means nothing to me. I need an answer now. Can I use this data set or not? So lack of practical guidance. So it goes both ways. There's frustration in both directions. Those are kind of the current challenges. So I know I have a very short amount of time, and I have a feeling I went over. So if you want to get in touch or look further into our work, here's our contact information.
And then I leave the floor to Professor Vittorio Murino from the University of Verona in Italy, but also currently member of Huawei, the research laboratories of Huawei Technologies in Dublin. So he's going to tell us about this interesting experience really working across the two worlds. Vittorio, the floor is yours.
So I titled this my presentation as a computer vision and machine learning, the revival of an old story, and I will say why at the end. So let's start with my activities. So what I'm interested in is actually analyzing behavior, human behavior, but also animal behavior, like for example, for mice. And you can see here some examples. For example, you can see some public areas in which people is in a way chatting and interacting. You have public spaces, you have fighting, you have group activities. You have also trying to understand what's going on when you, in a way, grasp a battle to, in a way, predict the intention. This is actually what I'm interested in, and what I did actually when I was the director of the Department of Italian Institute of Technologies, which is called PAVIS, Pattern Analysis Computer Vision. So we worked a lot on behavior analysis in general, so in computer, in video understanding, image understanding, and social behavior, group behavior, crowd behavior, and social interaction. So we were also interested in multimodal sensing, so addressing also, we develop also one of the first acoustic camera, which is now going to be commercialized in a way. We are spin outing this company that's still under construction, let's say. And also we also have an area which was interested in neuroscience, and specifically neuroimaging, for understanding behavioral phenotypes in animal, especially mouse, which is actually one of the most studied animals. And it was also interested in brain imaging, essentially. So all this stuff was functional to some applications which are related essentially in the security and surveillance, and also for smart environments, smart cities, smart reactive environments, and mobility and transportation. And also we have as application, of course, in biomedical market, but essentially also in industrial machine vision. And actually, this is actually an old story in the sense that in the industry, at least the industries we were in contact, actually we worked a lot in this part of machine vision, industrial vision problems, essentially automation and inspection. So let's start first as one of the most interesting issues in the security application, which is for identification. Essentially, this means how to identify the same person in different areas and in different environments, in different times, essentially, for example, from outdoor, indoor, in an airport. And this was not based on face recognition, but only based on the appearance, so only based on the clothing the people is wearing. So this is actually one of the most studied and interesting topics in academia, but also in industry, especially in the eastern part of the world, which we're mostly interested. There are a lot of companies working in identification. So this is actually one point of connection between academia and industry so far. A lot of context, but I would like to shift to one of the main issues in industry, so the hard industry, at least in Italy, which is essentially industrial automation. Essentially, what we can do here is a sort of linking machine learning, vision, and robotics. And in this example, which is actually was a project that we carried out some years ago, we were interested in analyzing and inspecting small engines and gears from the avionic industry. So this is actually the pipeline, let's say, the processing pipeline of the data. So we have some sensors which acquire data. For example, here you can see in a pipeline, in a sort of conduct or duct in which we need to understand the defects, and if there is some debris or some other defects inside this tube, this duct. And we, in a way, put inside this probe to understand the defect, detect the defect. So what we needed essentially is to build the sensors because it was not available commercially, to acquire data, to annotate the data, and which is actually consuming, costly in time, so not always possible. And in the end, we have this AI part, which in a way try to understand from the image you see if there is a defect or not in the pipe. So this is actually a classic, let's say, visual inspection problem, and we were involved in this model checking and inspection of these complex avionic components. You can see here an example, which are pieces not so small, quite large and heavy, and we have to understand how, from the point of view of model checking, but so all the components are placed in the same in the good position, the same position, not to be delivered without some components, and also for inspection, so to detect defects or in these ducts, or try to, in a way, see some other detected defect on the surface of the object. So this was done essentially previously by manual visual inspection. You can imagine that this quite old-fashioned inspection was efficient and depends much from the operator, but it was of course prone to errors after a few hours, also maybe also 1 hour. The operator is tired, is bored, so the inspection, the manual inspection was not so good, and we tried to making this process more performing and more effective and repeatability. So having a degree of quality quite high and constant a long time. And this is actually another example, more focusing on this duct conductor. You can see some classes of example. And we use here, needless to say, some deep learning approach. Okay, you can see some example here. We can show that, for example, here it is not defects in the duct, but sooner or later we will find some problems and we detect correctly. This was a project in collaboration with Avio Aero, which is a company, General Electric company, but situated in Italy. Another example was about digital textile. So also in this case, the goal was really to inspect the yard. And so it's not a defect, also not to detect the defects of the complete clothing, but we still operated at the level of the yard. And so, for example, the dimension of the word, the waste assessment, the presence of naps, the status of the bale, these are all problems at a very low level of the textile industry, which still was so far faced with other approaches, and we want to use here cameras and machine learning techniques. And then we have another couple of approaches regarding predictive maintenance. For example, trying to understand the correct functioning of machines producing the urn by acoustic listening, by the sound this machine are producing. And of course, there is another problem which we call process control, which is actually monitoring of the personal behavior, even for safety, but also for effectiveness of the process, in the sense that these people also are looking at they do some operations which are obviously repetitive, and we need to know if these operations have been performed completely, fully, and effectively. So this can be also another goal for this kind of industries, and also for other industries, I suppose. And then we had another couple of examples for eyewears. For example, we needed to build an automatic system for detection and classification of defects in eyewears. The goals here was this visual inspection. Even in this case, the inspection was manually, so there is an operator. A lot of operators actually looking at the glasses and see there are defects. And we want to automatize this process using cameras and robots. And so the technological challenges here is that normally we didn't have so large number of training examples, for example. And also the complexity was due also to sometimes the defects were not always declared. So some defects were also unknown in some sense. This was done in collaboration with a big industry of glasses. You can imagine that we cannot deliver this. And lastly, this was actually the inspection of ceramic tiles in a gas turbine chamber. And you see here that the ceramic tiles were pretty resistant, but in time were subject to cracks, erosion, chipping, and you can see here that we have to control these ceramic tiles, but you can see on the right the picture of the dimension, and going into these chambers was a bit complicated, and also the fact that this operator should be also well skilled. So what we do here is essentially build some robots, like you see in example in the bottom left. Now, okay, just looking into these chambers and delivering a camera, going around and looking at this torus and all the tiles, so that we can in a way detect the defect and giving a map of the effect of the tiles. So to conclude, artificial intelligence, which is the topic of this event, and specifically what I'm doing, and also the other colleagues before me, Rita, and also after me, is doing computer vision and machine learning, are living this new resurgence, and this thanks to the deep learning approaches, which made this possible, made possible something which 20 years ago were not possible, or at least we thought at the time it was not possible. But the problems actually, and also the techniques, actually deep learning are only essentially neural networks. The problems and also the technologies was already there 50 years ago. And from my experience, essentially the problems are many, the applications are very broad, and starting also from the classical industrial project and industrial problems like visual inspection. But of course, other applications can be tackled like surveillance, automotive, retailing, biomedical, and many others. And going back to our expertise about social behaviors, actually in this, especially in this period, we have to face other problems, and the problems we actually faced years ago, just like estimating interpersonal distance, just looking at the gatherings and grouping activities, now are becoming more and more important, unfortunately, for the pandemic situation we are living.
And we move to our last but not least speaker, Alessio Del Bue. Alessio is the director of one of the biggest group in the Italian Institute of Technology. And for those of us that follow the news on newspapers about technological advancement, he's often in the news for the work he does in connection with all type of real world bodies. So Alessio, welcome, and the floor is yours.
Thank you very much, Alessandro, for the presentation. I will go quickly through the place I'm actually working now, that is the Italian Institute of Technology, which is an institute that is based in Genova, Italy, and it was funded like 15 years ago, almost, with a budget of 90 million euro to perform research that could impact the technology of the Italian and beyond institute. So here we have just a show how the IIT is distributed around the world. Of course, the main place where we work in Genoa, but we have several centers that are all around Italy in relation to university where we work on. Business model is similar between Fraunhofer and Max Planck in Germany. So we are trying to spread out our efforts in research all through the Italian territory. We are started, as I said, some time ago. We have already 13 years, but in general, we are pretty young given the, let's say, the life of other institutes worldwide. So at the moment, we are 1,700 people with a pretty good gender ratio. So we're almost half between men and women working in research. And one of the mission of the Institute is really to do technology transfer. And this is witnessed by the number of, let's say, funding we are able to catch from industry. Since 2009, our overall budget in commercial projects, so project funded by industry, is around 65 million euro. And also the other projects like competitive projects, at the European level also raise pretty much of a percentage. So we are almost 30% funded by external budget, given the Italian funding we receive. We also pretty much active in startups. So we have almost 23 startups that has been launched. Some of them with standing, of course, on their legs and producing, let's say, new workplaces. And also more than 40 plus startup projects that are in general in incubation in Italy as well, and almost ready to go in the market. One other successful way to work with the industry is also to do joint labs. So in general, there are labs that in practice are made with a joint effort between IIT and other, let's say, companies where the effort sometimes is half and half. Some people come to IIT to get training, and we do joint work together. So we have a kind of in-kind, let's say, financing. We have not only Italian companies, but foreign one like Nikon, IBM, Nissan, Honda Research Institute, and so on. So coming back where I'm working at the moment, I'm in this block of buildings, the white and black striped one, and which is called the Center for Human Technology. So it's one of the places where almost 300 people of IIT are working. This place also, as said by Rita, in Italy there are 3 ELIS units. Also IIT in conjunction with University of Genova is an ELIS unit. So we are working together to push forward the excellence in research on AI in Italy and Europe. In the let's say in the work we do similarly from Vittorio and the other people, we work a lot on artificial intelligence, and we work in 2 mainstream, but we call I'm not sure if you have ever heard this naming, but with these 2 naming, the spatial artificial intelligence and social artificial intelligence. In general, we work on autonomous systems that are able to perceive the world in 3 dimension, for instance. So understanding where they are located in how they can move around a place, and also a social part for which we are trying to understand the human behavior that interact with the autonomous device or just working in a single place. In this way, by unifying together the spatial part, so understanding how the 3D world is formed, and the social one, how people move around, we might be able to build up systems that are really receptive of the environment they live in. One example of this research we do is a technology transfer activity that we did in collaboration with a German company, Osram, the lighting company, during a Marie Curie project. This project was creating a smart lighting system called Scene Under Light that was able to understand the lighting in indoor places and change the lighting amount given the current lighting given by window or the general weather around. So these systems are installed in the luminaries, so in the lighting scheme on the top floor. They have a camera that can look not only where the people move, but also the action they do. So they can change the lighting given the activity people do. So we tested these systems in general scenario office building, and they are able to reduce the lighting to 60%. So giving major savings in the consumption of energy and a less CO2 carbon footprint for the building itself. Another project I would like to talk about is a bit different from the standard possibly project you see in AI. Is an European project, H2020, of 3 years, called MEMEX, and is a project that tries to help marginalized individuals and communities. So how it does that? It creates an AI assistive technology that is able to make evident the life of people that are normally marginalized as well. They use machine learning, computer vision, augmented reality to do so, and I will tell you in a second. The partnership is pretty much mixed between technology partners like Italian Institute of Technology and commercial partners like Ernst Young, that is helping us in doing also the commercialization, further commercialization of the system, and also social stakeholder that test the app with the individuals. So the system, the technology embodiment of this system is an app that can essentially connect the physical world to the digital world. So in practice, we can attach, anchor digital information, like in the picture on the left, which is a museum, to objects in the world. So providing the way to visualize also digital information. And we don't stop only to this. We also provide the way to create stories that are geolocalized inside the world. So essentially, what MEMEX do, it leverage information in order to create path around a geographical location that can be a city, telling a story which can be made by picture, videos, and so on. So it's like a sort of, let's say, Instagram, if you would say that, but that is grounded on the physical world, not only just on your phone as well. And for doing that, as I said, we can give information like images, videos, attach them on the map, like Google also do in Street View, but in an open source, like to say, format. So we also leverage street level images taken from different, let's say, repositories that can be given freely online, and everyone virtual full step, because the idea of MEMEX is that everyone can contribute with their own stories and their own, let's say, images. To conclude, this can be done just from the comfort, the safety of your home, as you always did during this COVID time, but also whenever you might be using the augmented reality we are trying to develop with this system.
Let me take this opportunity to thank all the speakers that have given really a great range of very interesting presentation. So we can now start with the question, and the first one comes from Gordon Rennie in the audience, and it is a very interesting question. I'm going to read it and then shortly elaborate on it. When working with industry, who guides the science direction of research? Do you go to them with ideas, or do they come to you with questions? Do you feel in control of your research or not? So what is interesting here is that in general, what in particular funding agency advocate is to have the industry in the driving seat, or to let the industry guide. Or, I mean, at this point, going to the question, I wonder whether we should maybe advocate more for a loop, right, between the two. As you have collaborated with a lot of industry and you coordinate the efforts, what are your thoughts about this point?
My experience is actually that the companies, at least some companies, not all have some products, right? So you have some activities and products. So you are not going there to propose your ideas for research, but if you go there, you in a way plan in advance that this company is working in some of activities you are interested in, and you should stay close to these activities. There is not such freedom of doing research as one likes if you go to a company. So maybe it's better to stay. I should say also if you go to a research institute, because in any case you have to, in a way, agree on your research directions. We should comply with the research direction of the institute or the group where you are going to.
Thank you. Rita, I don't know if you want to add something.
I think that the connection and the interaction with industry is changing a lot in the last few years. Because until a few years ago, especially in computer vision, they asked us a very specific, simple question. Now they are more interested in a large question, how can innovate, can transform. One term that we are working a lot is digital transformation. So how can they use computer vision, but in general, machine learning and AI for all the supply chain and all the cycle of the life of the product. And also, for instance, there are many questions about ethical issues, as Olivia discussed before. So I give you an example. I presented you the experiment we did with the Tetra Pak that is about ergonomy. So it's something that is not related to the privacy, but the well-being of the worker. But at the same time, we experimented the system in Saudi Arabia, because in Saudi Arabia was allowed. Instead, in Italy, we had some problem. So we should discuss together, and together with the Italian and European Council, in order to understand in the GDPR the right of innovation and the right to do something that is in favor of the worker and in favor of a better work, and not just only because of privacy. So in this case, it was just only to construct a better machine for humans and for workers. So it was something good. So, and this is an example. We started to work together after a long discussion. So it was not because they asked something specific, but they discussed how can we improve the connection together. And I like a lot this kind of interaction with the industry we are doing.
Thank you very much. Another interesting question that comes from the audience is in particular directed to Stefan, but I will ask Olivia to answer too. So can you give some examples of explainable outcomes or explainable AI in industry? What are some key elements that we still have to solve for explainability? I think this is interesting from a technological point of view, in the sense that explainability helps us to better understand how to use artificial intelligence. But I think from a philosophical and ethical point of view is very important and very interesting too, especially when AI makes decisions about people. So Stefan, can I ask you to answer the question from a technological point of view, and we can hear then from Olivia about the philosophical aspect. Stefan.
Yeah, thanks very much. I have to admit that this is an area that we are actively looking into. We are looking into solutions that are already in the market that we could potentially use to explain some of the outcomes to our clients ourselves. And we're also looking to build kind of smaller solutions for easier models ourselves that basically have visualizations of different activation weights and the different layers. I'm curious to learn more about this as well. So I don't have a direct or concrete answer for this right now.
Olivia.
It's by no means an easy question. It's one of the big problems that we've been trying to tackle as well. One of the ways that we look at it is whether the explainability is being asked for in terms of process or outcome. We also hear a lot of the call, and you'll see on a lot of different AI ethics policies, is the principle of transparency. And that's usually coupled with this explainability problem. And that whole fact is towards we want a transparent view of how these decisions are being made. There are two different types of transparency that you can ask for. And that is the process transparency versus outcome transparency. Process transparency focuses on what kind of input is the model taking in, what is the model itself, what data are you feeding it, entirely the process of how the decision is made. Outcome transparency is asking, why was this decision made? So where we're seeing the big problems is the outcome transparency. You don't necessarily need the process transparency in terms of explainability. It's the black box problem. Does it really matter what's going in? Yes and no. But to the average individual, they're not going to care. They're going to care about the outcome transparency. Why was this decision made about me individually? And why, coming from, I'm going to bring in the philosopher perspective real quick here. Coming from the philosopher perspective, why does this matter? Why are we so obsessed in a way about this explainability problem? And it's the fact that we as humans have this almost fear and aversion to uncertainty. We don't know the exact reasons why these decisions are being made. For example, with people, for example, Alessandra, I can ask you to make a decision and I don't know exactly how your brain came to that decision, but I can ask you, I can have that interaction and then gain that certainty for myself that, okay, our values are in alignment. I can't do that with a model. I can't sit down and ask an AI going, did you consider this way? Did you do that? Are our values actually aligned? So that's an answer and not an answer all at the same time. It's a big problem that we're still tackling. And it is an important one based off of if we don't have this explainability level, or at least something that makes people feel comfortable and certain, there will be no trust in these systems.
Thank you. So there is a question for Alessio, which I'm going to read. So impressive number of startups. What kind of support have you found is ideal for supporting startups? Which is a very interesting question because, you know, there is a pressure in particular on academia research to produce startups, but at the same time, what do we really need in order to be conducive to that type of outcome?
Okay, thank you, Alessandro. So it's an interesting question and is also a complex problem to solve as well. I can tell what we do at IIT at the moment to support possible startups, which is a good option for like postdocs as well. If they don't want to go industry or they don't go to research, they have the way to build their own company as well. So the Institute facilitate with a set of incubators, of course, and some funding for postdocs that they want to do this story real. So they have 1 year or a couple of years of funding for making ready the technology while we give support for finding possible investors. Of course, Italy is has not the range of, let's say, investment on startups like other countries like UK and other, for instance. So also we search out for foreign investors, and this is the procedure, finding for investors and helping supporting the researcher for making ready the technology more than a proof of concept level. But the idea is always this one, and it has to be clear that it has a limited time of extent of time. Then if the project works and can go on his legs, okay, that's it. Otherwise, this is going to be a retarget or coming back to research or something else.
Thank you very much. Stefan, maybe you can add some considerations to this, given that you have actually founded a startup starting as a PhD student at the time you were in your PhD studies.
Yeah, thanks. I think it very much depends on the type of company that you're trying to build and to start up. Service companies, you know, inherently are easier to start, as you might have a revenue straight away by providing your expertise. Whereas if you are trying to build a product company, you're going through the so-called valley of debt, where you actually have to provide a minimal viable product in order to earn money. And I mean, the ideal solution, you know, very much depends on what you're trying to achieve as a spin-out company. So support that would be there. There's monetary support, but there's also support of maybe incubation spaces, accelerator spaces, expertise for people that maybe have a very technological background to understand the commercial aspects of running a startup and running a company. So bringing a whole ecosystem together like that, I think, is what is required to successfully spin out a business.
Thank you very much. So there is one very precise and specific question for Rita. Can you tell us something more about the Artificial Intelligence Academy? Is its role limited to education, or does it also ease the transition from academia to industry? How can an individual join it? And, you know, it's interesting to hear about this specific point, but maybe also if Olivia can tell us a little bit something, given that she has done this transition in the very recent times, so maybe she can add context about how it happens, let's say here in Scotland in particular. So Rita.
Yeah, actually very often the term academia, AI academia or something like this is used by company to discuss about the possibility to do lifelong learning and so on. In our case, is a very general initiative. In Modena, we have three different academia. One is Cybersecurity Academy, and the other one is Automotive Academy, the biggest one, because since we are in department into Ferrari, we have a lot of companies working in automotive. Ferrari, Maserati, Ducati Moto, Lamborghini, all of them are connected with us, and also we created the AI Academy too. The best idea is to work together, not only for learning. At the beginning, companies asked us some information about learning something about deep learning or so on. We accepted them in our university courses. So if they want to come, we created specific courses for them. But what is more important, we started to create a joint lab. So to have some project to discuss. Now in Modena, we are building a new building, actually, and part of this is supported by Emilia-Romagna region and part from Confindustria, that is the union, the association of companies, just to have a space to stay together, not just only for the incubator. What Stefan said before is very important. But in this period of crisis and according to the small situation in the small cities in Italy, probably the companies find many places to stay. But what is important is to have a place where to join with the student, to join with expert, and to discuss something. So we started something very simple for free. Like for instance, whenever we have a seminar, whenever we have some initiative, we spread it to everyone. So in the last month, we had some seminar from Toyota, from Ferrari, from Nvidia, from other one, and we spread it to the company just to have the idea to work together. And this is good. It's something springing up from the bottom up, from one side.
Fantastic. Olivia, can I ask you, including some maybe advice on how to make this transition from academia to industry after PhD studies or after earlier studies too?
Absolutely. I think I'll start with a piece of advice then, and that is to ask yourself seriously what level of industry you're looking to enter into. You can either go the route of actually a think tank or a research center. Specifically also, I'm speaking more from the ethics and AI perspective here, but also in terms of AI. There are a lot of even non-for-profits that sponsor research in this space. So if you want to move out of academia, but still enjoy the research aspects to it, then you're looking at more of the research centers, the think tanks. That is more individual research based. But if you want that more team development side, then you are looking directly into industry. And there's a lot of opportunity out there, especially if you've done research in AI before. Look for companies that align with the research that you've done for your PhD, that can incorporate parts to it. Companies are actually very happy to hire that. They're looking for that hands-on experience, and that not even hands-on experience, but that knowledge base that is still quite niche in its day. Again, in terms of AI ethics, that's a whole nother ballpark. We are mainly consultants and volunteers at the moment as we're working to establish a bit more of a set field and industry here.
Thank you very much. Thank you very much. There's an interesting question for Vittorio, but I will ask Alessio to answer too. So in cases where human inspection is replaced by non-human inspection techniques, do standards exist to ensure the repeatability and reliability of the technique? Do you need to conduct a probability of defect detection study to gain confidence in the technique? Now, the question is very specific, but I think the problem is much more general. Unlike other technology, artificial intelligence depends on data. It's not the type of thing that you can give a piece of software and then expect it will work forever, always in the same way, consistently. And most importantly, the user plays a major role there. So Vittorio, how do you see this problem to bridge a little bit the gap between something you do in the laboratory and something that ends up being used in reality? And then Alessio too, if you want to add your considerations about this point. Vittorio, please.
Yes, actually, it's not an easy question, in the sense, not an easy answer, in the sense that it depends much of the problems you are facing, and because so if you are detecting some specific defects and you have a certain rate of production, you can understand actually given your data, because at the beginning you still need to validate your algorithms, right? So you still need, the company has usually an idea of the errors, so let's say a human operator can do, and you want to, in a way, reach 1/10 of this accuracy. So what normally is doing, you can collect data, label data, and you try to detect your, let's say, defects in your data set. But of course, the reality is another story. So the maximum you can do, I don't think there are standards. So what you can do is just to validate your algorithm as much as you can. And maybe, and there is also the possibility to, in a way, tune your algorithms in depending also on so what you want to reach. So the number of false positive versus false negatives in order so to increase more, this is more technical stuff, but you need to reach some trade-off between precision and recall. But still, you have to do it using the data you collect for developing and validating your algorithms. And when you go, let's say, in the real world, in the real production phase, you still need to monitor from time to time what happens, not to lose.
Unless if I can ask your considerations too about this point.
Yeah, I think starting with the question I seen, the fact that the people will be replaced in a complex visual inspection task, it's very hard to say. Actually, in the experience we had, this is not often the case. But actually, we had an experience with Brunello Cucinelli, which is a famous fashion, say, luxury company, for which we try to actually create a visual inspection for textile, but in which the human was always in the loop, in the sense that the human becomes the supervisor of the AI algorithm instead of being actually substituted by it, because the human can always spot where the mistakes, can always increase the data set for the objects, because he has the way to learn out of the box if the textile changes, because for many industries you have a high throughput of new material. Of course, the problem is starting to be new. Okay, indeed, you hope that you have a very complex model that can generalize through different type of defect, but we are pretty far from it. So I believe more in a visual inspection system that goes together with the classical human one, and they grow together. And really, the person that was doing the repetitive and very tiring effort has to do a higher level job at this point in helping the machinery to do better rather than being substituted from it.
Thank you very much. So one question that is interesting looking more or less at all presentation is that so now in particular, Victoria and Alessio just finished to speak a little bit about applications that are very much technological and concern machines, automation, which is a little bit of what was the before last trend in artificial intelligence. But more and more, the focus is on people, on analyzing people, on understanding people. So I'd like to ask in particular Rita and Stefan, what do you think about this? Why is this happening? And what are the most important challenges in going in that direction? So bringing AI, understanding people. So Rita.
This is so important for us, not only for me, but in general for Italy, since we created in the next national research plan one specific line on a human-centric AI that is from one side for ethical and trustworthy AI, but especially for AI for human, and also AI about human. So the human behavior understanding is becoming one of very important issue, because in the next future, I believe that AI, embodied or physical or not, AI and human will strongly collaborate together, and we need to understand each other. So I need that people understand our behavior, our body language, our human expression. We know that there is a big hype on that, that's starting from big companies for face detection, for privacy issue. So we must to be very conservative in the term of GDPR and the term of the experience of the single privacy issue of the single person. But at the same time, human behavior understanding, it's important. What I showed you in just only one slide is what we created in Modena that is really common to many other similar approaches. That was about the COVID area to understand the risk of proximity between the people. So from one side, okay, in computer vision, you can detect the people, try to guess the distance in 3D. But what is more important is to understand the type of interaction between people, because if there is a mother with a son, it's different that there are two people that doesn't know each other. And also it's important to understand the risk of the area. So this kind of technique should be generalized, can be used. Now we applied our system in the whole of the hospitals, in the public offices, in many different places, to understand how the people can behave each other and also can interact with an AI, because the system look the distance between the people and say, come on, please move because you are too close to another. And you understand the people understand and try to interact with that. So this is a new paradigm that is starting to working, and I'm sure that will be the paradigm of tomorrow, to work together.
Thank you. Stefan, can I ask your opinion on this point?
Yeah, specifically with the introduction of any systems, intelligence systems or not, interacting with humans, we see that depending on the environment, the human will, in a sporting environment, for example, the human knows that it is monitored. It is monitored. Performance is taken off those devices, and especially in a professional environment, those performance criteria might determine if they get a new contract, if they will play in the next game. So there is basically a two-way interaction between those intelligent systems and the human might actually try to influence that system. So in the sporting environment, again, people will try to manipulate sensors because they try to figure out how the data, how the insights are derived that are delivered as actionable insights. So the human might, carry the sensor for longer, carry before games, after games, just to get more distance onto it and manipulate the system. And the other aspect of a kind of intelligent device that we have with the air quality monitor is to look at human behavior and understand if the humans are actually taking actions based on the recommendations that a system provides. So if the air quality monitor, for example, asks to open a window or to start an air purification device or anything like that, you know, do you keep on recommending the same things without any impact, or do you start to learn how to interact and maybe, you know, alternate your recommendations on that level? So there are many aspects to that question.
Thank you very much. So there is an interesting question, another interesting question. I think the speaker have alluded to this, but wonder if anyone could please comment on the ability of AI at the level shared this evening, or in combination to explain themselves. Have the solution move beyond this? Without precise project specification, close working on project, it would seem that there may still be different expectation on the research side and that of industry. I think in particular, I will ask Alessio to tell me something, and then Vittorio. I think there is a little bit a gap between how AI is presented in media, science fiction, etc., where it seems something really in condition. I think the use of the word intelligence is very misleading here. But what actually happens in reality, where at the end of the day, we train systems to address very specific problems, and anything else cannot be addressed with the same system. You have someone to change the system, change the data, change the problem if you want to address another application domain. So is there really a gap between the expectations of people about artificial intelligence and the reality of artificial intelligence as it works now? Alessio, if you can tell us something about.
Yes, indeed, there is. And this is a matter of providing, let's say, the right information to the public as well. Of course, many times this is AI seen as a magic wand, but as you said, we are very good in creating AI systems that solve specific tasks in a well-constrained world at the moment. Of course, we are trying to do better day by day. And one of the examples you can see is the autonomous driving. Of course, this is a major problem that has to solve several tasks: perception, of course, planning, and driving the car in crowded environments, so on. So this is not an easy task, but these systems are starting to be really complex and having different modular dependencies, which are very difficult to predict. For this reason, the stress testing of these systems is always delayed. Of course, you didn't see a car still driving alone in many places. Of course, in Italy, in many places, you wouldn't even dare to drive a car alone, because at least for my place, the streets and places are very tiny, and other driving behaviors that are making difficult everything. Indeed, we have to be careful, and also in the way to certify the functioning of these systems is also very hard, and this links to the previous explainability, let's say, question we had. We were not very sure if the system can interpret the things in the right way, and this is something we have to push further in research, and we need to work really a lot on this for making this type of very well deployed system in reality.
Thank you very much. Vittorio, if you want to add something to this point.
Yeah, actually, so I think we are quite far away from the creation of an intelligent machine in large sense. Now there are words which are called artificial general intelligence, AGI, which are actually seems to be addressing some specific topic of human intelligence in the large, but so this is called also common sense, but we are still far away and still at the level of research. Of course, the closer, the more specific the problem, the better we can solve it. And nowadays, we are addressing much better problems that in the past we were not so good. Actually, so there is a story in the sense that in the 80s, in computer vision, actually the people tried you saw a lot of papers which were addressing generic or general recognition systems. And if so, yeah, I am enough old to, in a way, remember some recognition system which is called visions or acronym. And actually, they realized that in the end, this system were fully fledged in the sense that they were consisting in sensors, feature extraction, knowledge-based, because at that time we had knowledge-based systems to recognize everything. But in the end, so this is actually good for papers, not so good for, in a way, real and industrial applications. And now we moved to more specific problems, and we are able actually to solve, in some sense, more specific problems. But once the variability of the real world is a bit not controlled, so we are not so safe in delivering a product for this kind of applications. But deep learning actually helped a lot, at least helped to move 10 times the community we had some years ago to work on these subjects. And I guess that in some years, let's say, we can say something more about moving towards more intelligent systems.
Yeah. Can I add just a very small things about what Alessio said, told before about the example of autonomous driving and explainability? Yeah, we need two things. We need, for one side, something that is very accurate and with high performance, but at the same time, we need something that is explainable. When we say explainable, we see explainable for designer, explainable for adopter, and explainable for final user. So our three different dimensions, all very important, because explainable for designers means to try to do something better. Explainable for user means to accept to use this system instead, for instance, something human-based. And acceptable for human is something for societal sustainability. That is really so important. In autonomous driving, this is really one key point. In Modena, we have this area that is called MASA, Modern Automotive Smart Area, where we have a number of sensors from the municipality, and we can test something that is around in order to understand what's happened and try to explain why, for instance, one car is stopped or not because of an obstacle. We cannot do a lot of things according to Italian regulation, but it's something we are working on. I believe, I'm very optimistic that in the future we can do something in this sense.
Thank you very much. And as I'm really exploiting our speakers here that are very kind to stay with us, I think we can conclude with a very interesting questions that come. And each one of you, I'm going to ask everybody to reply. Would you advise a young student to pursue studies in artificial intelligence, whether it is at the master level, at the laureate level, how we call it in Italy, or at the PhD level? So do you think artificial intelligence is today, for a young person, a nice field to invest on for their own training? So if I can start from Olivia.
Asked the philosopher the question, but yes, I think artificial intelligence is here to stay. It'll shape our future. It's a very great field to invest your time into. Again, I can't speak from an actual AI developer point of view, but I can do a subtle plug here for the fact that ethics and the work in the ethics of artificial intelligence will be the next wave coming, and that can't be animated. So that's also a nice benefit. So from an ethics standpoint, at least a master's in that direction is very well worth the time. A doctorate if you can, but absolutely a master's.
Thank you very much. Stefan.
I wholeheartedly agree. You know, it's a topic and an area that is here to stay and will influence many developments in the years to come. I think the question regarding masters versus PhD really depends on the interest and of that particular person. You know, do you want to actively engage in developing systems, maybe systems with industry, systems that will be used directly by end users? Then you might not need a PhD to actually do it. A lot of the complexity of AI and machine learning systems are now abstracted to a level that a good developer can implement good machine learning solutions. But if you want to tackle, you know, fundamental problems of artificial intelligence, for example, the ethics of it, then potentially going down a PhD route might be advisable.
Thank you very much. Alessio.
I'm sure it's the right time, at least as far we can predict, because this is there is high level of acceptability of this technology that I don't think we witnessed before. So people are ready to work in this field and supporting this field. Even all the research community is helping a lot in producing code that actually works for people to reuse and to proceed further in this field. I mean, I think there's been level of advancement that we couldn't believe in the last few years, and it's gonna keep up. But we're gonna hit the limits, and the limits are gonna be very interesting to solve as well. So it's gonna be a surprise, and it's gonna be exciting for sure.
Great. Vittorio.
Yeah, actually, I'm selling my product. So I think even at the master level and also PhD level, for sure, a master and machine learning, computer vision, AI in general is worth to be pursued. And I also think that also the what Stefan mentioned before, so the data science field actually can benefit a lot from these studies, and so not only limiting, let's say, not only regarding the technological plan in vision or in signals like sounds, but yeah, also other kinds of data like log cybersecurity anyway. And from the perspective of data science, all the other sciences like biology, medicine can for sure take benefit from these studies. And yeah.
Thank you very much. And Rita, for a conclusive word.
Of course, I agree with my best friend Vittorio. The idea to do an AI curricula in this moment, it's a perfect timely. We created in Modena a new curriculum of AI engineering that put together not only the theory, but a lot of labs and a lot of application, but also something for the future, like a quantum learning course. So I think that now it's a time to study that and to be ready to work in the industry with these courses. If you don't have this information in master, do the PhD or some school to do that.
Okay. So thank you really very much to all the speakers. You have been great. I think it has been very interesting. Thank you for answering the questions of our audience. And thank you very much, everybody, for posing a really very nice range of very interesting questions that touch a little bit all the aspects. And I thank as well the organizer, the Italian Institute of Culture and the Italian Chamber of Commerce in the UK. So Simona Manca and Davide Bagna, thank you very much for their organization. And thank you very much from myself as well, Alessandro. And I hope to meet you soon again, all of you, hopefully face-to-face and not virtually. Thank you very much, everybody. Thank you. Thank you. Bye-bye.